Welcome to Maths and Statistics class. In today's class, I'm looking at financial mathematics, and I'm focusing specifically on the calculation of simple interest, compound interest, and discounting. Let's start with simple interest. Under simple interest, the interest does not earn interest on it. And the formula for calculating the future amount or the total sum of money in the account after a given period of time is future value, that's the total sum, equals the present value, principal amount, or the amount invested now, multiplied by 1 plus Rn. R is the rate of interest, N is the number of periods. Exercise 1. 1,000 is invested at the beginning of year 1, and simple interest is added each year at 10% per annum. How much income will the investment generate by the end of 2 years? So in your solution, you must first of all look at the variables that are given in the question. So what we have in the question, we have the PV, the amount of money invested now, that's 1,000. We have the rate given, R is 10%. Convert that to a ratio that is going to be 0.1. What else do we have? We have N, which is 2 years, N 2 years. So what will be the solution? Copying from the formula, bring down the formula there. You should have future value, or the total sum of money, future value or the total sum of money equals to the present value, which is 1,000, multiplied by, that's multiplied by 1 plus our 0.1 multiplied by 2, close brackets. So tap that in your calculator. You should have 1,000 multiplied by 1.2, and finally that will be 1,200. So how much will be in the account at the end of 2 years? That's going to be 1,200 in the account. That's the amount that investment will generate. Compound interest. Under compound interest, interest earns interest. The interest earned is added to the principal before the next interest is calculated. So in that way, interest is earning interest. And this is the formula for compounding interest. The future value will be present value multiplied by 1 plus R to the power N. 1 plus R to the power N, that's the discount, that's the compounding factor. That's the compounding factor. So let's look at the exercise. 1,000 is invested at the start of year 1, and compound interest is added each year at 10% per annum. Calculate the value of the investment at the end of 3 years. So identify the variables that are given. You have your PV given, present value, that's the 1,000 invested now. What else are we given? The R, our R is 0.1, 10%, 0.1. What else do we have? N is given as well. N is 3 years. N is 3 years. So how much will be in the account at the end of 3 years? Interest compounded per annum. Interest compounded per annum. That is going to be your future value equals to, what's the present value? 1,000. That's multiplied by 1 plus, what's the rate? 0.1. Okay, close brackets there, and raise that to power N. What's the N? N is 3. So raise that to power 3. Raise that to power 3. You should have, put that in the calculator, is 1.1 raised to power 3 multiplied by 1,000. You should have 1,301. $1,301 dollars. Of course, that's how much the investment will generate. That's how much the investment will generate. Exercise 3, sorry, I want to deal with the situation where interest is compounded in periods less than a year, and you need to adjust your R and adjust your N as well. So let's look at this question. Exercise number 3. Let 15,850 be an initial deposit into the savings account with the annual nominal rate of 5%. What's the amount in the account after 4 years if interest is compounded quarterly? Let's identify the variables. We have the PV, which is 15,850. 15,850. What else do we have? Annual rate is given as 5%, so our R is 0.5. But because we are compounding interest quarterly, there are 4 quarters in the year. So if the annual interest is 5%, the quarter interest will be 5% divided by 4. So 5%, 0.05 divided by 4, you should get 0.0125. 0.0125. Then what else are we given? We are given the 4 years. That's our N equals to 4 years. But because we are compounding 4 times each year, that's per quarter, we have to multiply that 4 years by the 4 quarters in the year, and that will give us 16. So tap that in your formula, bring down your formula. So how much will be the future amount? Future value will be equals to PV, that's the 15,850, multiplied by 1 plus rate 0.0125, then raise that to power 16. Raise that to power 16. Okay, so that's our power 16. So how much would that be? If you put that in the calculator, it will be 1.0125 to power 16 multiplied by 15,850. Your answer should be 19,335.25. That's what your answer should be. So that's how much will be in the account after that period of time. Finally, let me talk about discounting. Discounting is simply reverse compounding. So discounting is reverse compounding. Discounting takes into account the time value of money. The money you have now is more valuable than the money you will receive in the future. This is how we do discounting. Take the future value, bring it down to the present value. So present value will be equals to the future value multiplied by 1 plus R to the power negative n. 1 plus R to the power negative n, that's our discounting factor. So let's see. Solution. Calculate the present value of 80,000 at the end of year 5 if an interest rate of 10% per annum applies. So if the interest rate of 10% per annum applies, we need to discount 80,000 to some present value. So 80,000 received at the end of 5 years, how much is that equal to in the now terms? So what's the PV of that value? PV will be equals to the future value, 80,000. The future value, 80,000, multiplied by the discounting factor, which is 1 plus R. R is 0.1. Raise it to power negative number of years, 5, to the power negative 5. To the power negative 5. So that's the power negative 5. So how much would that be? When we tap that in the calculator, it will be 1.1 raised to the power negative 5 multiplied by 80,000. That should give you 49 674. Right, so that's how much 80,000 is worth in now terms. Thank you so much for listening. Watch out for more videos.